All right, I'm on page 442. This is screencast number 2 for lesson 2 of Unit 8. And we need to talk about deep currents. Remember, previously in the first screencast, we were talking about surface currents and what caused those. All right, movements of ocean water far below the surface are called deep currents. And deep currents are caused by differences in water density. Remember that density is the amount of matter in a given space or volume. Remember the equation for density is density equals mass divided by volume. The density of ocean water is affected by two things, salinity and temperature. Salinity is the measure of the amount of dissolved salts or solids in a liquid. Okay, you can think of it as the saltiness of a liquid. Okay, so where was I? The density of ocean water is affected by two things, salinity and temperature. Salinity you can think of as kind of the saltiness of the water. The more salt or other solids that are dissolved in the water, the heavier the water is, or the more dense that the water is. Okay, so water with high salinity is denser than water with a low salinity. And cold water is denser than warm water because in cold water, the water molecules are able to be packed a little bit closer together than in warm water. Okay? All right. Over here, we're going to talk about this convection current down at the bottom in a minute. But let's talk generally about what convection currents are. A convection current is the movement of fluid because of density differences. Here, specifically, we're going to talk about the density being the density of water, but a convection current can be set up in pretty much any fluid. We have convection currents that work in the atmosphere. We have convection currents that work in the ocean. We have convection currents that drive plate movement in the mantle because warmer molten fluid rises. A little bit cooler molten fluid will sink. All those things set up convection currents, which is just the movement of fluid because of differences in density. Okay? All right. When we get a convection current set up, it's like a giant circulating loop, and surface currents make up the top part of that conveyor belt, and deep currents typically make up the bottom part of the belt. Okay? So water from surface currents may become deep currents in areas where the water density increases. So water that was part of a surface current may cool, become more dense, and sink to become part of a deep current. Okay? Water that's in a deep current may warm and rise to the surface to become part of a surface current. So it all circulates. How do convection currents transfer energy? Okay. First of all, we do need to make sure that you understand that convection currents transfer energy. Surface currents are going to take heat energy and move it to areas that don't have as much heat energy. So we're going to have surface currents carrying warm water to cooler regions. Okay, remember that near the equator, we're going to get a lot of heating from the sun. Towards the poles, we don't get as much. So one of the things that's going to happen is the water is going to absorb that heat, and water close to the equator will eventually move away from the equator towards colder regions to try to redistribute that heat. Okay? All right, I'm going to zoom out just a little bit so we can look at this entire convection current here. All right. Let's start with A. Surface currents carry warmer, less dense water from warm equatorial regions toward polar regions, where the water eventually cools, and because it's cooling, it's becoming more dense and it's sinking. That water may become part of a deep current now. Deep currents carry colder, denser water in the deep ocean from polar regions to other parts of the earth, back towards maybe equatorial regions, where water will be heated and warmed and rise, and the whole cycle starts over again. Okay, so a convection current is this whole big loop of circulating water, because the water at the top of the loop is less dense because it's warm, And the water at the bottom of the loop is more dense because it's cool. Okay. All right. And over here is just a reminder to you about convection currents in general. Convection currents occur because warmer fluid is less dense and rises, while cooler fluid is more dense and sinks.